Okay, so the first examples video, I've got a set of examples, all meant to be 700 to 800 level questions, so they should be harder than the average question. I haven't seen them before other than just copying them down here. They're a random selection, and I'm just going to try and go through relatively slowly and just sort of explain not just how to do them, but also what clues there were in terms of why I chose the technique I did. They should all be available from the previous videos. So let's get started. So this first question, we need to know how many integer values y can take. And we've got a modulus equation here. And so what I would say is, why don't we just start sketching out a graph? And as soon as we've got the graph sketched, we should basically be done. So we've got x there and y there. And let's just start off, as always, with moduluses. We want to go to the highest number that is sort of interesting. And so we'll go to x equals 5. And at that point, we know that y takes the value 10. Just plugging it in. So we've got 10, 5 there. And then the lowest value y can take on the other end, we'll go to minus 5. At minus 5, we've got minus 5, we've got y equals 10 again, I believe. No, minus 10. So we've got minus 10 down there. Okay. And then between those 2 points, nothing is changing in terms of the, so for example, above x equals 5, well, what form does this take? Well, it's x plus 5 minus x minus 5. So in other words, it's just 10. So it's a straight line like that. Between these 2 points, we just have to be able to connect them up. At 0, it's 0. So we can connect them up like that. And then below x equals minus 5, well, it's going to be minus x minus 5 minus x plus 5, basically. And so sort of, redoing all of that, that just ends up looking like that. And so how many integer values can y take? Well, it can take anything between 10 and minus 10, including 0. So the answer is going to be E, 21. So you can see sort of a graph has sort of answered that question. Otherwise, I think that would be relatively tricky. Okay, which of the following represents the complete range of x of which this thing is less than 0? So here, again, just going to rely on graphs. So let's factorize straight away. X cubed, 1 minus 4x squared is less than 0. Well, again, there's that sneaky difference of 2 squares thing cropping up. 1 minus 2x, 1 plus 2x is less than 0. Okay, and so now I'm just going to sort of sketch this out and mark on the important points. So that's going to be minus a half, and 0. And it's a negative quintic. So effectively there, it's going to, as x gets very large and negative, it's going to be up here, and very large and positive, it's going to be down here. And now I just sort of need to join these points up such that it does the following. So it can only cross there. There's only one way of sort of joining these, which is to do that, if that makes sense. And so now that we've done that, we can just immediately see, when is it less than 0? Well, it's between 0 and minus a half and above a half. So which one is that? Above a half, and so we're going to be at C, I believe. Okay. Slightly weirder one. Let's start by multiplying through by mod x, because we know that that's positive. So x is less than x mod x, and we're only allowed to do that because it's positive. Now I can take everything to one side. X brackets 1 minus mod x must be less than 0. Okay, and so this is a bit annoying. Now we need to sort of go through cases. And so how can we make that less than 0? Well, it's if they have different signs. So, well, this part is plus if x is greater than 0, and this is this part is minus if x is greater than 1 or x is less than minus 1. And so we've got plus and minus only if x is greater than 1. Okay. And then minus plus, well, that's going to be sort of the other way around. So this needs x less than 0. And minus 1 is less than x is less than 1. And so those are both true when minus 1 is less than x is less than 0. Okay, and so our answers in terms of a number line are that if that's 0 there, x can be sort of here, or it can be here, anywhere that way. So now we have to just look at, of those, which ones must be true? Well, does x have to be greater than 1? No. Does it have to be greater than minus 1? Yes, actually. There's no values that are not greater than minus 1. So that's our answer. Just checking the rest. No, none of the rest look correct. Okay, mod x is less than x squared, which the following must be true. Well, that one, I think, so before, the reason that I didn't go and sketch graph is because I don't know how to sketch the graph of x over mod x or x mod x. Whereas here, I know how to sketch both these graphs. So if I can, I'm always just going to use graphs because they're an extremely easy way to solve them, because x squared is just going to look like that. And mod x is just going to look like this. And they both go through the point minus 1, 1, and 1, 1. Those are those points. And so mod x, so we want the blue line to be below the red line. So I suppose x has to be bigger than 1 in size. In other words, x squared is greater than 1. That's what we want. Okay. Ooh, nasty one here. How many solutions will this equation have? So again, pretty nasty to actually figure this out. So I'm just going to, again, default to graph sketching. That looks about as simple as we can get it. So let's just start off with the thing on the right, 8 plus x. So that goes through minus 8 and has a gradient of 1. So sort of looks like that. Goes through 8 there and that. Okay. And then the other one, well, slightly nastier. So let's just sort of get an idea of what's going on. We've got, where's the important point? Above x equals 4, that's when we've got x plus 3 minus, and that other one's negative above that point. So minus x minus 4. And so that's just going to be 3 minus, so that's just going to be 7 above x equals 4. Fine. Interesting solution. So 4. There we go. So it's just going to be flat at that point. And then below that point, until the point minus 3, we're going to have, well, at minus 3, what's it doing? We've got minus 3, so 0 minus, so 4 minus 3, so 7. So I think we're at minus 7 there. So down here, minus 7. So we can sort of say that's what's going on. And then just like the other question, below that point, we're going to end up with just minus 7. So the answer to how many solutions is 0, because there's no intersections. What is the minimum value of fx? Well, effectively here, very, very horrible to actually solve. I'm not going to even try and sketch that. There's 3 modulus signs, so I'm just going to try plugging in values for x. And if I can find the smallest value, then that's one of the answers, then that must be the right answer. So, for example, I'm hoping that we can get to 3, basically, because then we know we're right. So let's just try what are the points to try it? X equals a quarter for that first bracket, x equals 3 for the second one, and x equals -1. Those are the obvious points to try. So if x equals a quarter, we've got 0 plus the 11 over 4 plus 5 over 4. So that's 4, okay? If x equals 3, we've got 11 plus something, so who cares? And x equals -1, we've got 5 plus something, so who cares? So 4 is going to be our answer. That's as small as we can make it. What is the sum of all possible solutions to... Okay, so we've got mod x plus 4 squared minus 10 mod x plus 4 minus 24 equals 0. Well, that is actually just a quadratic. So we can factorize that, hopefully. I'll say that a equals mod x plus 4, just to make this clearer. Then this is a squared minus 10a minus 24 equals 0. So factorizing that looks like 12 and 2 work. So a minus 12, a plus 2 equals 0. So then we've got mod x plus 4 equals 12, or mod x plus 4 equals -2. Well, that won't have any solutions because moduluses have to be positive. So we don't even have to worry about that. And then this other one, x plus 4 equals plus or minus 12. So x equals 8 or minus 16. And so the sum of all the possible solutions is -8. So D. For how many? Oh, okay, that looks a bit nasty. So again, I'm hopefully clearly going to rely on graph sketching. So what do we got here? Well, y equals 12 minus 2x. Well, okay, we can sketch that. So that's just a graph that goes through the point 12. 12 minus 2x, so it's got a sort of steep gradient like that. And we also want the modulus of y to be less than or equal to 12. Well, in other words, what's that doing? That's meaning we can't go past 12 or -12. Okay, so then, therefore, I just want to know, well, what values are, how many values of x do we have? So at -12, at y equals -12, we've got -12 equals 12 minus 2x. So in other words, x equals 12, I believe. Okay, so that's the point 12. And so we've got solutions to this for all the values of x between 0 and 12. So the answer will be 13. Why was this? For what value of x will y be greatest? Well, the top is always going to be positive, so we need to make the bottom positive, but we can't. So the greatest is actually the least negative. So y equals mod 3x minus 5 over minus x squared plus 3. Well, okay, I could do a bunch of stuff here, a bunch of clever working out, except for the fact that it's literally just asking us which value of x makes y greatest. So let's just try some values, e.g. the answers. Oops. Let's go back to this. So, okay, let's try -5. So we get, well, let's just have a look at this. We want to make, we probably want to make the, yeah, let's just try them. -5, so that's going to be 20 over minus 28. That's one option. 3 over 5. That's going to be, or minus 3 over 5. That's going to be well, we want to make this as small as possible in terms of negative. So just looking at this, well, okay, fine. Let's just minus 3 over 5 will lose to 3 over 5 just due to the symmetry. So let's just do 0 and 3 over 5. So 0 gives us 5 over 3. Well, minus 5 over 3. So that's not going to win. 3 over 5. That's 9 over 5 minus 5. So 16 over 5 all over 3 over 5 squared plus 3. Jesus. 9 over 25 plus 3, which is 84 over 25. Wow, this is a nasty question. 84 over 25, the minus up front. So that's going to be 16 times 5 over 84, the minus, is equal to minus 80 over 84. So this guy's still winning. And then 5 over 3. Could he win? Maybe. Great. So 5 over 3, that's oh, of course. Wow, I'm silly. Wow, that was very stupid of me. There was a much easier way of doing this question. We already know that I can't believe I didn't spot this. We already know the whole thing is going to be negative overall, and so the best we can possibly do is make y 0. In other words, y equals 5, x equals 5 over 3, because then the top bit is 0. Wow, stupid there. Okay, how many integers that satisfy this inequality? Is greater than 0, or greater than or equal to 0, or less than 5? Okay, well, how can we get this to be satisfied? Well, let's start off with what integers have we got? We've got 4 heading downwards. So does 4 work? So at 4 we've got plus, plus, plus. So we've got 4. In fact, I'm just going to write them out. 4, 3, 2, 1, 0. Still heading that way. So 4 will work. When we get to 3, nothing has changed. So that's fine. We get to 2. The bottom is 0, which is undefined according to the GMAT. So that doesn't count. Then we get to 1. The bottom is now a minus. So that's not going to work. So that won't work. When we get to 0, still not going to work. When we get to, so no, minus 1, minus 2, minus 3, minus 4, etc. Minus 1, still nothing's changed. So nope. Minus 2, the top is 0 there, and that is greater than or equal to 0, so that works. Minus 3, the top is 0, so that works. Minus 4, both of them on top have now become negative. And for all numbers, so it doesn't work. And for all numbers lower than that, it's going to be negative. So the answer is D, 4. If n denotes a number to the left of 0, so okay, so n is less than 0, such that the square of n is less than 1 over 100. Okay, so n squared is less than 1 over 100, which means that, translating that, n is less than 1 over 10, or n is greater than minus 1 over 10. So in other words, we must have, because it's less than 0, we know it's between, so let's just draw it on the number line, 0, minus 1 over 10, somewhere in this little region, that's n. The reciprocal of n must be, well, it's certainly going to be negative, and it's certainly going to be, well, it's going to be 1 over 0 is infinite, and the smallest it can be is minus 10 if we do 1 over blah, blah. So it's between minus 10 and minus infinity. So less than minus 10. There we go. Ooh, okay. If x is greater than y squared is greater than z to the 4, which of the following statements could be true? Ooh, nasty. Okay. Well, okay, so I think I'm just going to try and do a number line here. Looks like a very nasty question, to be honest. So x is greater than y squared and z greater than, so if x is greater than y squared, can x still be greater than y? Well, that certainly can be true. And can y still be greater than z? Yes. Yeah, I mean, this first one is obviously just can be true. Okay, can we get it such that z is greater than y is greater than x? So if we just choose some numbers, if z equals, so we need z to the 4 to be smaller than y squared, but bigger than y if it's z. So if z is 0 point, if z is, I don't know, very nasty question. Z is a quarter, for example, then, and y is a half. Does that work? Y squared can be greater than z to the 4. Wow, no, oops, sorry, z is a half and y is a third, for example. Then y squared will be greater than z to the 4. That's true, but z is greater than y, okay? And x is greater than y squared. Okay, well, really pretty nasty question. Okay, I'm going to reconsider this question. X over y squared, the original thing, is greater than 1. And y squared over z to the 4 is greater than 1. So in other words, this first thing, what does this tell us? Well, it tells us that x is positive because y squared has to be positive. Whereas the rest of them, we don't have that same restriction. So therefore, we can't get 2 to work because, can we? No, we can. X is a quarter, for example. What a horrible question. Yep. Fine. So that works as well. And then X is greater than Z is greater than Y. So on X positive, Z can be some small positive number and Y can be some big negative number. So yeah, I mean, all of them can work. Okay, fine. If mod X greater than 3, which the following must be true. Well, so in other words, on our number line, 0 is there, 3, 3, minus 3. So we know we're over here. And so which must be true? Well, does X have to be greater than 3? Nope. Does X squared have to be greater than 9? Yep. And does X minus 1 have to be greater than 2? Well, let's just see where X minus 1 is. So X minus 1 is over there, and X minus 1 is over there. So the modulus of that is always going to be greater than 2. So actually that one is true. And so it's 2 and 3. Okay, this, well, let's just rearrange this. 12 is less than 7 minus X. And so X is less than minus 5. which of the following must be true? So we've got our number line, 0, -5, x is that way. X is greater than 5, well, obviously not. Mod x plus 3, so let's take a look at what x plus 3 is. X plus 3 is that way, so it's over there. And mod x plus 3 is greater than 2. Well, yes, that is greater than 2 in size, magnitude. Minus x plus 5 is positive. Well, x plus 5 is anywhere that way. So minus of that is anywhere that way, and that's positive. So that is true. And so it's 2 and 3 only. Okay. So we want to know the possible values of x. Inequality, pretty nasty. I'm going to go with graphs just to give us an idea of what the possible values of x are, what the sizes are. So we've got 12x minus 5. In fact, I'm going to divide both sides by 6 first, just to make this a bit simpler. 2x minus 5 over 6 is greater than 7 over 6 minus x. Okay, so on the left we have our x is 5 over 12. That's our interesting point, 5 over 12. And he's got a gradient of 2, so he's going to be quite steep. Fine. And the other one, x is 7 over 6, which is somewhere over here. And he's got a gradient of 1. So never intersecting him there. And he's sort of doing this, something like that, which the following cannot be the, and we're saying that this 2x over 5 has to be greater than this thing. So we can have any two big positive values. Okay, we have quite big negative, so we can have that. We have that. Who couldn't we have? We can't have. So what basically has this shown us that we can't have? We can't have very small negative numbers because actually, oh, I need to redraw this a bit better, don't I? So that crosses at 5 over 12 with a gradient of 2, so that's 5 over 6. Whereas this guy crosses at gradient of 1, so 7 over 6. So he's actually up here. Okay. So then we can't, as I said, we can't have very small negative values. And so we can't make C because we can't have very small negative values and a very small positive value. The rest of them we can just about get. How many integer values of this? Is it less than 10? Okay, well, it's pretty nasty, but it's not going to be infinite because they're all positive. So, well, let's just take a look. Like, you know, let's sort of go with -5, 4, 3, 2, 1, 0, 1, 2, 3, 4, 5. Sort of that sort of list. Let's see what's at -5. We've got 8. So -5 isn't going to work. What about -4? 7. Nope. That's not going to work. What about -3? Are we there yet with -3? -6. So 6 plus 2 Nope, still not there. Okay, -2, it's going to work, I believe. So because we get -5. Yep, so he works, which means he will work, 1 will work, 2 will work. What about 3? 0 plus, yep, 3 will work. What about 4? 1, 5. 4 doesn't work because then it's 1, 5, and 4. So, and then it's not going to work. It's going to get bigger after that. So how many have we got? 1, 2, 3, 4, 5, 6. 6 values. Okay. M squared is less than 225. So M on our number line is between -15 and 15. That's where M lies. N minus M, so well, N equals M minus 10, let's say. What is the difference between the smallest possible integer value of 3M plus 2N and the greatest? Okay, well, so let's just put it in terms of M. So we want 3M plus 2N, which is 3M plus 2M minus 10, which is 5M minus 10. And so basically what's the biggest and the difference between the smallest positive integer value and the greatest? So, well, what's the smallest possible integer value is going to be minus, so it's the actual integer value it can be is 14. -14 is what it's actually allowed to be because it can't be -15. So we can get -70. So we can get -80. And then the biggest again is 14. So we can get to 70. We can get to 60. And so I've gone slightly wrong apparently. Wow, it's 3M plus 2M minus 20. I'm incredibly stupid. So I believe that becomes minus 90. And no, an irritating question. So except we need the integer value of 3M. We need the integer value of, we only need 3M plus 2N to be an integer. So we just need this to be an integer, in which case M can be, oh, that's really nasty. M can be less than -14. It can be -14.8. So actually we can get all the way down to minus 98, 99, I believe. No, minus 94 and all the way up to 54. Wow, horrible question, which is a difference of 148. There we go. Ouch. These are 700 to 800. So xy is greater than 0, so either they're plus plus or minus and minus. And x minus 2, y plus 1 is less than 0, so either x is greater than 2 and y is less than -1, or x is less than 2 and y is greater than -1. Which of the following must be true? So okay, well then let's start drawing out what we've got on a number line. So in this first case, x is greater than 2. that's our x, and y is less than -1. So y is that way, but that they're not. We need them both to be positive or both to be negative, so that just doesn't work at all. In other words, we can only have the other case, so x is less than 2, so he can be there, and y is greater than -1. So in other words, that's one case, or x is negative and y is also negative, so in that case. So these are sort of two cases, if that makes sense. And so this is our, I really should have labeled this. This is our x and our x. This is our y and our y. So x is less than or equal to 1. That wasn't true. 0 is less than or equal to y. That's not true. X is less than or equal to... Wow, these questions really are nasty. What does this thing mean? Well, it means either x minus 2 is less than or equal to 2 minus x, or x minus 2 greater than or equal to x minus 2. Okay, well, that one's a bit useless. So the previous one, that means that x is less than or equal to 2. There we go. That one is true. Wow. Okay. If d is greater than 0, and okay, so immediately make me think number lines. 0. So our d is that way. And 0 is less than 1 minus c over d is less than 1. Okay, well, let's just rearrange that a bit. C over d is less than 1, and d is greater than 0, so we can rearrange that. C is less than d, and minus c over d is less than 0. Again, we can multiply that out. So because d is greater than 0, so minus c is less than 0. So in other words, c is greater than 0. Okay, so c is greater than 0 and less than d. That must be true. C is greater than 0 and less than d. So c over d must be less than 1, correct? C squared plus d squared is greater than 1. I don't think that's true. No, because we don't, all we know is, like, for example, they could both be just above 0. So that's not true. And so it's 1 and 2. Okay, I'm just going to sketch this out. Where's the interesting point? Well, it's when x equals 3, I believe. Is that right? 3. And then it's got a gradient of a third, so quite shallow. And we want it to be less than 2. Fine. Which of the following must be true? Well, clearly A doesn't have to be true. B maybe. C no, that's not going to have to be true. Actually, C maybe. D definitely isn't true from our sketch, and so let's just check where it intersects. So we've got this right-hand side is when it's so basically we've got both sides. We want to find when it intersects. So we've got minus x over 3 plus 1 equals 2, in which case minus x over 3 equals 1, in which case x equals minus 3. Okay, so that's a minus 3. So x does have to be bigger than minus 4. That's true. Whereas the other way around is x over 3 minus 1 equals 2. So x equals 9. So that's at 9. So x doesn't have to be less than 8. So the answer is C. X is less than y is less than z, but x squared. Okay, so I'm just going to... well, of course, these are all greater than 0. That's almost useless. But we do know that x is less than y is less than z. Effectively, the way I look at that is that the size of the distance from 0 of x has to be the biggest, and he's the smallest, so he has to be the furthest away from 0. So we could put x has to be somewhere over here. He has to be negative, effectively. Then y has to be less than z, but he has to be further away from 0. Yep, so we can put him, we have to put him there. He again has to be negative. And then z could be here, or he could be here, as long as he's smaller than. So z can be plus. So x is negative, y. So x is a minus, y is a minus, z is a plus or a minus. And so which one must be positive? Well, that's negative. In fact, we can just immediately so negative, positive, and then could be either. So in fact, we can ignore the anything with an odd z power, because in those cases we're always going to have confusion, and so B must be the answer because it's the only one where z is not ambiguous, because it's z to the 4, so that's positive. And that is it. So hopefully that all made sense, and these were, apologies for the questions that I found a bit tricky, but hopefully, I mean, these are all 700 to 800 level. So hopefully that helps and backs up sort of the learning from the other video. And hopefully you can see it was using the stuff I talked about in the previous video.